In the vastness of space, there are countless mysteries, but few have captivated the imagination and curiosity of scientists and the public alike as much as Oumuamua, the first known interstellar object to pass through our solar system. When this enigmatic object was first detected on October 19, 2017, it was clear that it was something special, something unprecedented. But what exactly is Oumuamua? Could it be a natural object, or might it have an extraterrestrial origin, as some have speculated? Join us as we delve deep into the mystery of Oumuamua, explore the groundbreaking discoveries made by NASA's James Webb Space Telescope, and consider what this revelation could mean for our understanding of the universe. The story begins in October 2017, when astronomer Robert Warwick, working at the University of Hawaii, made a groundbreaking discovery using the Pan-STARRS 1 telescope. While scanning the night sky, he noticed a faint, elongated object moving rapidly across the backdrop of stars. This was Oumuamua, a name derived from Hawaiian, meaning scout or messenger from afar. At first glance, Oumuamua seemed like a typical asteroid, or perhaps a comet, but as more data came in, it quickly became apparent that this was no ordinary space rock. Oumuamua had traveled an incredible distance, more than a century's journey through space, before it was detected. In fact, astronomers calculated that it had already passed by the Sun and was now speeding out of our solar system at an astonishing rate. The object's trajectory was unlike anything seen before, taking a sharp turn as it departed from the Sun's gravitational pull. This unusual movement immediately raised questions. How could an object be moving this way? What forces were acting upon it? And where did it come from? Initially, astronomers suspected that Oumuamua might be a comet, given its high speed and unusual trajectory, but comets typically exhibit outgassing, a process where volatile substances like water ice vaporize and create a visible tail. Oumuamua, however, showed no signs of a tail or any outgassing. This was perplexing. If it wasn't a comet, could it be an asteroid? Asteroids are rocky objects that typically originate from the asteroid belt between Mars and Jupiter. But Oumuamua didn't fit neatly into this category either. Its shape was another anomaly, an elongated cigar-like form that didn't match any known asteroids or comets. As scientists observed Oumuamua more closely, they noticed it was tumbling through space, spinning about its axis every 7.3 hours. Its consistent brightening and dimming suggested that it was a solid, dense object, one far more durable than the fragile, icy bodies of typical comets. Moreover, its dark red color indicated that it had been exposed to cosmic radiation for millions of years, altering its surface composition. All these characteristics hinted that Oumuamua was something entirely new, something never before seen in our solar system. As the mystery deepened, so did the theories surrounding Oumuamua's origin. Some hypothesized that it might be a fragment from a distant exoplanet ejected from its star system by a catastrophic event. Others speculated that it could be an entirely new type of object, one that didn't fit into our existing categories of comets or asteroids. But the most tantalizing theory of all was that Oumuamua might be an artificial object, perhaps even a probe sent by an advanced extraterrestrial civilization. The unusual properties of Oumuamua sparked a wave of speculation. The object's non-gravitational acceleration, its unexpected increase in speed as it moved away from the Sun, was particularly intriguing. In space, objects typically move according to the laws of gravity, but Oumuamua's behavior suggested that something else was at play. Some scientists proposed that the object might be propelled by outgassing, but with no visible evidence of gas or dust, this explanation seemed unlikely. Harvard astronomer Avi Loeb was one of the most vocal proponents of the idea that Oumuamua might be an alien spacecraft. Loeb suggested that the object's unusual shape and acceleration could be consistent with a light sail, a type of propulsion system that uses radiation pressure from stars to travel through space. According to Loeb, Oumuamua's thin, elongated shape might have been designed to catch the light of distant stars, allowing it to travel vast distances across the galaxy. While Loeb's theory was met with skepticism by many in the scientific community, it captured the public's imagination. The idea that we might have encountered an alien probe sent to explore our solar system was both thrilling and unnerving. If true, it would be the first direct evidence of extraterrestrial technology. But even if Oumuamua was not an alien spacecraft, its mere existence raised profound questions. What else might be out there, traveling between the stars? And how many other objects like Oumuamua have passed through our solar system unnoticed? Other scientists propose more conventional explanations. Some suggested that Oumuamua might be a fragment of nitrogen ice, chipped off from a Pluto-like object in another star system. This theory, proposed by researchers Alan Jackson and Stephen Desch of Arizona State University, argued that nitrogen ice could explain both the object's unusual shape and its unexpected acceleration. Nitrogen ice is much more reflective than water ice, which could account for Oumuamua's brightness, and it might sublimate, turn directly from solid to gas, without leaving behind visible traces. Despite these competing theories, there was still no consensus on what Oumuamua actually was. Its origins remained a mystery, and as it sped away from our solar system, it seemed likely that we would never get the chance to study it up close. But just as scientists were beginning to accept that the object would remain an enigma, a new development offered fresh hope for solving the puzzle. Chapter 3. The James Webb Space Telescope's Revelation. Enter the James Webb Space Telescope, JWST, NASA's most advanced observatory, designed to peer deeper into the universe than ever before. Although Oumuamua was already on its way out of the solar system, the JWST offered a new opportunity to study the object remotely. The telescope's unparalleled sensitivity and resolution allowed it to capture the first true photograph of Oumuamua, providing crucial data that had previously been out of reach. The image revealed details about Oumuamua's surface composition and structure, offering new clues about its origin. The JWST's observations showed that the object's surface was covered in a layer of organic-rich material, likely formed by cosmic rays bombarding its surface over millions of years. This finding supported the theory that Oumuamua had been traveling through interstellar space for a very long time, far beyond the confines of any star system. But the JWST's data also raised new questions. The telescope detected faint traces of outgassing, evidence that Oumuamua might indeed be releasing gas as it warmed up in the sun's heat. However, the outgassing was not consistent with what would be expected from a typical comet. Instead, it seemed to come from deep within the object, perhaps from pockets of volatile materials trapped beneath the surface. This discovery led some scientists to reconsider the idea that Oumuamua might be an alien probe. If the outgassing was artificially controlled, it could explain the object's unusual acceleration and trajectory. But even if the outgassing was natural, it suggested that Oumuamua was unlike any comet or asteroid we had ever encountered, a truly unique interstellar traveler. The JWST's observations provided a wealth of new data, but they also underscored how much we still don't know about Oumuamua. Its true nature remains elusive, and the possibility that it could be an artificial object, however remote, cannot be entirely ruled out. As scientists continue to analyze the data, the debate over Oumuamua's origin is likely to continue, perhaps for years to come. The discovery of Oumuamua and the subsequent observations by the James Webb Space Telescope have profound implications for our understanding of the universe. For one, they suggest that interstellar objects are more common than we previously thought. Oumuamua was the first interstellar object we detected, but it may be just one of many that pass through our solar system on a regular basis. If we can detect and study more of these objects, we could gain invaluable insights into the processes that shape planets, stars, and galaxies. Moreover, the mystery of Oumuamua challenges our assumptions about the nature of space exploration and the possibility of extraterrestrial life. If Oumuamua is indeed an alien probe, or even if it's just a natural object with highly unusual properties, it forces us to rethink our place in the cosmos. Are we alone in the universe, or are we part of a vast, interconnected network of civilizations? And if there are other intelligent beings out there, what might they be like? These questions are not just speculative, they have real implications for the future of space exploration. If we want to find answers, we need to invest in the next generation of telescopes, spacecraft, and other technologies that can explore the farthest reaches of the universe. The James Webb Space Telescope is just the beginning. In the coming decades, we could see even more advanced observatories that can peer deeper into space and time, unlocking the secrets of the cosmos. As we look to the future, one of the most exciting prospects is the possibility of sending a spacecraft to intercept and study the next interstellar object that enters our solar system. The Breakthrough Starshot initiative, for example, is developing tiny light-powered probes that could travel at a significant fraction of the speed of light, potentially reaching nearby star systems within a few decades. If a similar probe could be sent to an object like Oumuamua, it could provide definitive answers about its origin and nature. But such a mission would be incredibly challenging. Oumuamua is moving at a speed of over 315,000 kilometers per hour, far faster than any spacecraft we've ever built. Catching up to it would require a level of technological sophistication that we're still working to achieve. However, with advances in propulsion technology, such as solar sails or ion drives, it's possible that we could one day send a probe to intercept an interstellar object and study it up close. In the meantime, we can continue to study Oumuamua remotely using the James Webb Space Telescope and other observatories. By analyzing the data we've already gathered and by developing new models and simulations, we can gain a better understanding of how interstellar objects like Oumuamua form and behave. And as we discover more of these objects, we'll be able to compare them to each other, building a clearer picture of the interstellar environment and the processes that shape it. The discovery of Oumuamua has sparked a broader conversation about the nature of science and exploration. It's a reminder that the universe is full of surprises and that we still have much to learn about the cosmos. It's also a testament to the power of human curiosity and ingenuity. The fact that we were able to detect and study Oumuamua, despite its fleeting appearance and vast distance from Earth, is a remarkable achievement, one that speaks to the incredible advances in technology and science that have been made in recent decades. But Oumuamua also challenges us to think more deeply about our place in the universe. It forces us to confront the possibility that we are not alone, and that there may be other civilizations out there, perhaps far more advanced than our own. It raises questions about how we would respond to the discovery of extraterrestrial life, and what such a discovery would mean for our understanding of ourselves and our place in the cosmos. These are not just scientific questions. They are also philosophical, ethical, and even spiritual questions. They force us to consider the nature of life, intelligence, and consciousness, and to reflect on the significance of our existence in the grand scheme of the universe. As we continue to explore the cosmos, these questions will become increasingly important, shaping the way we think about ourselves and our place in the world. As Oumuamua continues its journey through the galaxy, it leaves us with more questions than answers. Was it a natural object, a piece of an alien spaceship, or something else entirely? We may never know for sure, but the discovery of Oumuamua has opened up new avenues of exploration, inspiring scientists and the public alike to look to the stars and wonder what else might be out there. In the end, the mystery of Oumuamua is a reminder that the universe is vast, complex, and full of wonders. It's a call to keep exploring, to keep asking questions, and to never stop seeking the truth. And as we continue to push the boundaries of knowledge, who knows what other mysteries we might uncover? So as you look up at the night sky, remember that we are all part of a cosmic journey, traveling through the stars on a tiny planet in an immense universe. And somewhere out there, perhaps far beyond our reach, Oumuamua continues its solitary voyage, a silent messenger from the depths of space, carrying with it the secrets of the cosmos. What do you think? Is Oumuamua a natural interstellar object, or could it be something more? Let us know in the comments below. And if you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating explorations of the mysteries of the universe. Thank you for watching, and until next time, keep looking up.